Guys, in this video we will discuss about the isomorphism of graph. Okay, so what is the isomorphism of graph and under which condition we can say that the two graphs are isomorphic to each other? Actually, two graphs G and G dash are said to be isomorphic, that means equivalent to each other, if there exists a one-to-one correspondence between their vertices and their edges such that the incidence relationship is preserved. And in other words, we can say that the two graphs are isomorphic if they both contains the same number of vertices, same number of edges, the corresponding vertices have the same degree, and the incidence relationship between vertices and edges are preserved. Basically, the question is that how can we find that the two graphs are isomorphic or not? So, to find the two graphs are isomorphic, we have to check they contains the same number of vertices, the same number of edges, the degree of the corresponding vertices, and the adjacency matrix or the incidence matrix of both the graphs are same. If both the adjacency matrix and incidence matrix are same, then and also the first three properties are also hold, then we can say two graphs are isomorphic to each other. So now I just show you here two problems, that whether we can say two graphs are isomorphic by using their adjacency matrix and by their incidence matrix. So now what I say here, I just take here two graphs, and the question is that examine whether the following graphs are isomorphic. If you follow it very carefully, you can see that the total number of vertices here 4, and the total number of vertices in these two graphs are 4, and also the total number of edges here 5, and here also 5. So the first two conditions are satisfied. And now if we follow here that the V1, that here we get the V1 and V3, there are two vertices whose degree is 2. Also here W1 and W3 whose degree are 2, and corresponding the degree of the vertex V2 and V4 is 3, and also the W2 and the vertices W2 and W4 are also 3. So first three conditions are satisfied. Now we check the incidence relationship between vertices and edges. So here we just construct the adjacency matrix here. So we know that the adjacency matrix is a matrix which is vertex to vertex. So see here that and we know that the adjacency matrix, all the diagonals are 0 if there is no self loop, and that means the graph is simple graph, and we can say this graph is simple graph because there is no self loop or no parallel edges. So now we just construct the graph here. That is, see that V1, this is also an adjacency matrix, is also vertex to vertex, and now I will try to construct the adjacency matrix. That is, see here the adjacency matrix here that V1 is connected with V2 and V4, and there is no connection with V3. So we will put in the V2 and V4 1, and as V3 0. And now see the point V2 is connected with V1 and V3. So we put here V2 is connected with V1, V3 and V4 also. So the V2 to V2 is 0, and we put V2 to V1 is 1, V2 to V3 1, and V2 to V4 1. And now we check the V3, that is V3 is connected with V2 and V4, no connection with V1. So this will be 0, this will be 1, this is 0, and this is 1. And V4, that is also connected with V1, V2 and V3. So we put here V4 to V1 1, V4 to V2 1, and V4 to V3 1. And the diagonal elements of that adjacency matrix are always 0 for the simple graph. And now we will construct the adjacency matrix of the second graph. So similarly here we first construct the 4 cross 4 matrix, that is W1, W2, W3, W4, and see here all the diagonal elements are 0. So W1 is connected with W2 and W4, so I put here 1 in W2 and W4, and there is no connection since W1 to W3, so we put it 0. Similarly, W2 is connected with W1, W3, W4. So we put here 1, 0, 1, 1. And W3 is connected with W2 and W4. So I put here in place of W2 1 and W4 1. W1 0, W3 0, and W4 is also connected with W1, W2 and W3. So we put 1 1 1 and the W4 is 0. And see here, both the matrices are same. So now we can say that the given two graphs are isomorphic. And now I will show you another one. That is, if we consider these two graphs, these two graphs. See here, the total number of vertices in G1 is 4. Total number of vertices in G2, that is also 4. Total number of edges here also 5, and total number of edges also is here 5. So first two conditions are satisfied. And now check the degree of the corresponding sequence. Degree of U1 is 2, degree of V1 that is also 2, degree of U2 4, degree of V2 is 4, degree of U3 that is 3, degree of V3 is also 3, and degree of V4 is 1, and degree of U4 is also 1. So first three conditions are satisfied. So now here I want to construct an incidence matrix, and incidence matrix means the matrix is related to the vertex to edges. So see here that U1 is so first we consider the U1, U2, U3, U4 and U1, U2, U3, U4, U5. So see here U1 is connected with U1 and E3, and there is no connection with E2, E4 and E5. So here we put in place of E1 1 and E3 in place of E3 is 1, and the rest will be 0. Similarly, now check that U2 is connected with E5 and E2, and since U2 contains the loop, and see here U2 there is connection of U2 with E1. Yes, U2 is also connected with E1, so we put here 1 for E2 1. There is no connection with E3 and E4, so we put here 0. And since E5 is a loop, so we put here 2. Similarly, now check for the E3. U3 is also connected with E2, E3 and E4, and there is no connection with E1 and E5. So this will be, and U3, and now U3 is connected with E3, E4 and E2. So here we put, and there is no connection with E1 and E5, so we put here in place of E1 0, E2 1, E3 1, E4 1 and E5 0. And see here U4 that is only connected with the E4, so here we put 1 in place of E4 and the rest place will be 0. So this is the incidence matrix of the graph G1, and we denote it by IG1. Similarly, now we construct the incidence matrix of G2. So here we put the V1, V2, V3, V4, the vertices, and then U1 dash, E2 dash, E3 dash, E4 dash, E5 dash. See here V1 is also connected with E1 and E3. So put here 1 and 1, and the rest place will be E2 dash, E4 dash, and if there is no connection, so that will be 0. So now go to the point V2. V2 is connected with E1. V2 is connected with E1 dash, E2 dash, and E5 dash. So put here 1 1 0 0 and 2. Since E5 dash is the loop, and now V3, that is V3 is connected with E3 dash, E2 dash, and E4 dash. So here, and there is no connection with E1 and E5, so in place of E1 and E5 0, and E3 dash, E4 dash, and E5 dash respectively we put 1 1 1. And see here the V4 that is also only contain, that is only associated with the edge E4 dash, so we put here 1 and the rest will be 0. And here we get the matrix of the incidence matrix of the graph G2, and this is we denote by IG2. And see here both the graphs are same, so I can say that the graph G1 and G2 are isomorphic. Remind one thing, that if the given properties which I say that the number of vertices, number of edges, and if the matrices are not same, and any one of these four conditions will fail, any one of them will fail, then we cannot say that the graphs are isomorphic. And sometimes you have to remind that, and sometime we have to remind that you have to change the row columns for permutation, and you have to take the change of row and columns, and after the change of row and columns, if the two matrices are not same, then you can say that the two graphs are not isomorphic. This case may be happen. So I hope you understand. So thank you.